Hello, everyone. Today, we're going to explore the life of one of the greatest scientists of the 20th century, Robert Oppenheimer. He was the leader of the Manhattan Project, which helped the US develop the first atomic bomb, bringing World War II to an end in 1945. But behind the glory was a personal tragedy. He was betrayed by the US government and stripped of his power. Oppenheimer's story is not just about science. It's a powerful lesson on ethics, politics, and the price of knowledge. Let's dive into his dramatic life. Part 1. The Genius and His Academic Journey. Robert Oppenheimer was born into a wealthy and intellectually rich family. His father, Julius Oppenheimer, was a successful German immigrant businessman in the textile industry, while his mother, Ella Friedman, was a talented painter. Growing up in the intellectual environment of New York City, Oppenheimer was exposed to a high-quality education from an early age. His family owned an extensive art collection, and from a young age, he developed a deep passion not only for science, but also for philosophy, literature, and classical languages. From childhood, Oppenheimer displayed an extraordinary intellect and an insatiable thirst for knowledge. As a student at the Ethical Culture School in New York, he quickly excelled in the natural sciences, particularly chemistry and physics. But his talents weren't limited to science. He had an exceptional gift for languages as well. He could read and understand Greek, Latin, and French, and later mastered German, Dutch, and Sanskrit, allowing him to access a vast range of intellectual works. After graduating high school with outstanding achievements, Oppenheimer enrolled at Harvard University. There, he continued to prove himself as a remarkable student, completing his undergraduate degree in just 3 years instead of the usual 4. Initially, he was drawn to chemistry, but after being exposed to cutting-edge physics, particularly quantum mechanics, he decided to shift his focus to theoretical physics. Recognizing that the forefront of physics research at the time was in Europe rather than the US, Oppenheimer pursued further studies at the University of Cambridge under the mentorship of renowned physicist J.J. Thomson. However, he struggled with experimental work, which did not align with his natural strengths and way of thinking. As a result, he transferred to the University of Göttingen in Germany, where he studied under Max Born, one of the leading physicists in quantum mechanics. At Göttingen, Oppenheimer quickly became part of the scientific vanguard and made significant contributions to quantum mechanics. He and Born developed a key theoretical framework known today as the Born-Oppenheimer approximation, which separates the motion of nuclei and electrons in molecules. This work became a cornerstone in modern science and marked a turning point in Oppenheimer's career. After earning his PhD, Oppenheimer returned to the US and began teaching at the University of California, Berkeley, and the California Institute of Technology, Caltech. He quickly gained a reputation as a brilliant professor, admired for his deep knowledge, engaging teaching style, and ability to inspire students. Many young scientists who studied under him later became prominent figures in the field of physics. Beyond his scientific prowess, Oppenheimer had the soul of an artist. He loved poetry and philosophy and often quoted literary works in his lectures. He also had a deep interest in social and political issues, something that would later shape his career and life in unexpected ways. Oppenheimer's early years were not just the story of a scientific prodigy, but also of a broad-minded intellectual, constantly seeking knowledge across multiple disciplines. This strong academic foundation would ultimately prepare him for one of the most consequential roles in history, leading the Manhattan Project and developing the world's first atomic bomb. Part 2. As World War II escalated, the race to develop nuclear weapons became a critical part of military strategy. The US government recognized the urgent need for a comprehensive nuclear research program, driven largely by fears that Nazi Germany was working on an atomic bomb. If Hitler succeeded first, the consequences would be catastrophic. In 1942, the US officially launched the Manhattan Project, a top-secret initiative to develop nuclear weapons. When selecting a scientist to lead the scientific efforts, the Department of Defense considered many prominent names. Ultimately, they entrusted this monumental task to Robert Oppenheimer. This decision was controversial at first. While Oppenheimer was an exceptional theoretical physicist, he had never managed a large-scale project before and lacked a Nobel Prize, unlike some of his peers. However, he impressed military officials with his deep knowledge of physics, strong communication skills, and strategic vision. More than just a scientist, he had the unique ability to unite and inspire some of the greatest minds in the world. Building the Los Alamos Research Center. As scientific director of the Manhattan Project, Oppenheimer chose Los Alamos, New Mexico, as the project's central research site. He believed the remote location would provide maximum security and minimize the risk of espionage. At Los Alamos, he assembled a team of the world's most brilliant scientists, including Enrico Fermi, Richard Feynman, Niels Bohr, Ernest Lawrence, and Edward Teller. Many of them were European scientists who had fled Nazi-occupied territories. The atmosphere at Los Alamos was a mix of intense pressure and intellectual excitement. Oppenheimer was not just an administrator. He actively participated in scientific discussions, proposed solutions to critical challenges, and bridged the gap between scientists and the military. His leadership was essential in maintaining collaboration between these two vastly different groups. After years of research, Oppenheimer's team achieved a breakthrough. They developed two types of atomic bombs: Little Boy, powered by uranium-235, Fat Man, powered by plutonium-239. On July 16, 1945, the world's first atomic bomb was successfully tested in the Alamogordo Desert, New Mexico, in an event known as the Trinity Test. As the bomb detonated, creating a massive fireball and a towering mushroom cloud, Oppenheimer stood in silence, recalling a line from the Bhagavad Gita, "Now I am become death, the destroyer of worlds." This moment marked a historic scientific achievement, but it also raised a profound moral dilemma. Was humanity truly prepared for the devastating power it had just unleashed? The use of the atomic bomb and Oppenheimer's reaction. Less than a month after the Trinity test, the US dropped two atomic bombs on Hiroshima, August 6, 1945, and Nagasaki, August 9, 1945, killing hundreds of thousands of people. Although Oppenheimer had played a crucial role in developing the bomb, he had no control over how it was used. The final decision rested with the US government, and President Harry Truman believed it was necessary to force Japan's surrender. At first, Oppenheimer seemed satisfied with the project's success. However, during a meeting with Truman in October 1945, he made a shocking remark. "Mr. President, I feel I have blood on my hands." This statement deeply angered Truman, who saw the use of the bomb as a government decision, not a scientist's responsibility. From that moment, tensions between Oppenheimer and the US government began to grow. The fallout of the Manhattan Project. After the war, Oppenheimer became a symbol of scientific achievement and technological power. However, he was also haunted by ethical concerns. He opposed the development of the hydrogen bomb, a weapon even more destructive than the atomic bomb, putting him at odds with key figures in the US government, particularly Edward Teller and Cold War policymakers who pushed for an arms race with the Soviet Union. Tensions reached a breaking point in 1954, when the US government launched a security hearing to investigate Oppenheimer's past political affiliations and beliefs. Although he was never a spy or a traitor, the era of McCarthyism and Cold War paranoia led to his security clearance being revoked. Effectively, he was exiled from the heart of American nuclear policy. The Manhattan Project had propelled Oppenheimer to global fame, but it also marked the downfall of his political career. He had helped create one of history's most powerful weapons, yet he spent the rest of his life grappling with the moral consequences of his work. However, Part 3. The Tragedy of a Scientist. After the success of the Manhattan Project and the US deployment of atomic bombs to end World War II, Robert Oppenheimer became one of America's most celebrated scientists. He was hailed as the father of the atomic bomb, invited to serve as a senior advisor in government committees on nuclear policy. However, behind the fame lay a profound personal tragedy: moral anguish, growing conflicts with the government, and ultimately, betrayal by those who once trusted him. Moral dilemma. Initially, Oppenheimer did not openly oppose the use of atomic bombs on Japan. However, after witnessing the devastating consequences in Hiroshima and Nagasaki, where hundreds of thousands perished, many suffering from burns and radiation sickness, his stance began to shift. He believed that nuclear weapons should not be further developed or used as tools of war. Instead, he advocated for international agreements to regulate and control them. During a meeting with President Harry Truman in October 1945, Oppenheimer made a chilling remark. "Mr. President, I feel I have blood on my hands." Truman was reportedly enraged by this statement. In his view, the decision to use the bomb rested with the government, not a scientist. After the meeting, Truman allegedly referred to Oppenheimer as that crying son of a bitch, and vowed never to meet him again. Although Oppenheimer could not immediately change U.S. policy, he continued using his influence to oppose nuclear proliferation. He strongly objected to the development of the hydrogen bomb, H-bomb, a weapon thousands of times more destructive than the atomic bomb. This stance put him in direct conflict with powerful figures in the government, particularly physicist Edward Teller, a key advocate for the H-bomb. Conflict with the U.S. government. As the Cold War intensified, the U.S. identified the Soviet Union as its primary adversary. When the Soviets successfully tested their own atomic bomb in 1949, the U.S. government escalated efforts to develop the H-bomb as a deterrent. Oppenheimer, then serving as chairman of the General Advisory Committee for the Atomic Energy Commission, AEC, strongly opposed this initiative. He warned that an arms race would increase the likelihood of nuclear war and encourage other nations to develop similar weapons. However, President Truman approved the H-bomb program in 1950, and Edward Teller took the lead in its development. This further isolated Oppenheimer within the scientific and military communities. Simultaneously, government officials began questioning his loyalty. Amidst the Red Scare, the U.S. was gripped by anti-communist hysteria. Oppenheimer's past associations with leftist circles, including his wife Kitty Oppenheimer and former lover Jean Tatlock, both with ties to the Communist Party, made him a target for investigation. The 1954 security hearing, a bitter betrayal. The defining moment of Oppenheimer's downfall came in 1954 when the U.S. government subjected him to a secret security hearing to assess his loyalty. The hearing, orchestrated by the Atomic Energy AEC, lasted for 4 weeks and summoned over 40 witnesses. Key accusations against Oppenheimer included his past associations with Communist Party members, his opposition to the hydrogen bomb program, viewed as obstructing national interests, allegations that he delayed reporting knowledge of a possible Soviet spy at Los Alamos. One of the most damning testimonies came from Edward Teller, who, while stopping short of calling Oppenheimer a traitor, stated, "I feel that I would prefer to see the vital interests of this country in hands that I understand better and therefore trust more." Teller's testimony shocked the scientific community, effectively sealing Oppenheimer's fate. Though Teller later suffered professional isolation, the damage had already been done. Following the hearings, the AEC revoked Oppenheimer's security clearance, effectively banishing him from the center of U.S. nuclear policy. While he was not charged with treason, this decision was a devastating blow to his career and reputation. Once a figure of immense influence, Oppenheimer was now cast aside, a tragic ending for the man who had once led America's greatest scientific endeavor. Part 4. Legacy and Historical Lessons. Robert Oppenheimer passed away in 1967, yet his legacy continues to echo today. He was not only a brilliant scientist who helped usher humanity into the nuclear age, but also a symbol of the conflict between scientific intellect and political power. His story serves as a lesson in the complexity of ethical responsibility in science and the consequences of placing personal ideals within a ruthless political machine. 1. The changing perception of Oppenheimer. In the years following his death, Oppenheimer's image gradually rehabilitated. While in the 1950s he was seen as a security risk, by the late 20th century, he was increasingly recognized as a betrayed hero. In 2022, nearly 70 years after his infamous 1954 security hearing, the U.S. Department of Energy officially nullified the decision against Oppenheimer, acknowledging that he had been treated unjustly. This was a symbolic move to restore the honor of one of America's most influential scientists. Historians and scientists have also come to appreciate Oppenheimer's contributions beyond nuclear physics. He was one of the first voices warning against the dangers of a nuclear arms race, a concern that remains highly relevant in today's world. Science and ethics, an unanswered question. Oppenheimer's story raises a profound question. Should scientists be responsible for how their discoveries are used? During the Manhattan Project, Oppenheimer and his colleagues were primarily focused on solving technical challenges, without fully considering the long-term consequences. But after witnessing the devastation of the atomic bomb, Oppenheimer felt a moral obligation to prevent further nuclear proliferation. However, his efforts failed. The arms race escalated, and he was ultimately cast aside by the very government he had served. This highlights a crucial reality. Science cannot be separated from politics and ethics. Scientists are not merely neutral observers. They are sometimes forced to confront difficult moral questions about how their discoveries are applied. 3. Contributions to physics and nuclear science. Beyond his role in the Manhattan Project, Oppenheimer made significant contributions to theoretical physics, including gravitational collapse theory, foundational work that later contributed to black hole research, mathematical methods in quantum mechanics, advancements that paved the way for future developments. Mentorship and inspiration, training a new generation of physicists, some of whom later won Nobel Prizes. Additionally, he played a key role in establishing post-war research institutions, particularly the Institute for Advanced Study at Princeton, shaping the future of scientific inquiry. Lessons from Oppenheimer and the atomic bomb. The story of Oppenheimer and the Manhattan Project serves as a reminder of both the power and peril of scientific discovery. A single invention can reshape the world for better or worse. Political power can exploit science for its own interests, regardless of long-term consequences. Scientists bear ethical responsibility for how their discoveries are used. Today, as the world grapples with challenges like biological weapons, artificial intelligence, and climate change, Oppenheimer's story remains more relevant than ever. It forces us to ask, what can we learn from the past to avoid repeating its mistakes? Conclusion. Robert Oppenheimer remains one of the most complex figures in scientific history, a genius, a visionary leader, but also a man of deep contradictions and personal tragedy. He ushered humanity into the nuclear age, only to become a victim of the very forces he helped unleash. Although he was betrayed and politically exiled, his legacy endures, not just in the field of physics, but in the ongoing ethical debate over science and its consequences. His story is a stark reminder that science is not merely an intellectual pursuit. It has profound real-world implications that can shape the future of humanity.